Okay, we're going to take a look at Unit 1, Lesson 1, Practice Problems. And I'm not going to do all of the practice problems, just a couple, so that while you're working through your work, you can check with me and see if you get the same answer as I did. All right, so this first question is a little tricky because it's saying which square, the large, the medium, or the small, covers more of this area or space. And this one is a little tricky because it looks like the white square is covering more of the space. It does. It kind of looks like that. I have 1, 2, 3, 4, 5 of the large squares. So I have 5 large squares. So I'm going to just write 5 large. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 medium. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 small. Now I'm going to say right now, I know it's not the small, right? Because if I have 10 of the medium and 10 of the small, I know for sure that the green is covering more area than the small ones, the little orange ones, okay? So we know that this is covering the least space, okay? So I'm not even going to really focus on that. They have the same number of squares and this one's smaller, so we know it's definitely covering less of the space. Now, I want us to take a look at the green and the white ones, okay? So if I kind of like imagine sliding this on top of the white, I'm going to draw like a dotted line and show that this green one is more than halfway across the white square. And I can't really see how tall it is in comparison, but I can kind of estimate and know that if it's more than half this way, then it's going to be more than half that way. So one of the greens is covering about this much of the white square. See how I just kind of used the line here to show if I were to extend this square or even like reflect it like we did in the last video, if I take that medium square and I reflect it, you can see that it's actually covering more than half, okay? More than half of the large. So this area on the large square is the same as this area in the small one. And if you look, you can see that there are more greens than there are whites. So there's more of these medium size squares than there is this large one. So 2 of these is going to cover more than this square. Okay, so 2 of these green medium-sized squares are going to cover more area than the white or the large square, just because we can see that it's more than halfway across, more than halfway across. So I will say the mediums cover more of the plane because each of the medium squares is slightly larger than halfway across the large one. Okay, so the medium's going to cover more of the plane. All right, let's take a look at question number 2. I love this one. Draw 3 different quadrilaterals. A quadrilateral is a 4-sided shape. So we need to know that we're making a 4-sided shape, okay, with an area of 12 square units. Well, this is kind of fun. Let's think about multiplication facts that would equal 12. So remember when we looked in the last video, area is a length times width. So some people like to look at it as length times width. Some people like to look at it as base times height. Okay, so like I think both are good. Base times height. So we're kind of looking at it like this. Boop, boop, right? So if we know we have a length and a width, it's making that right angle. Okay. So we're looking for 2 factors that would equal 12. So we know that area is length times width or base times height. So something times something has to equal 12. Well, we just need to come up with 3 of them. So I'm just going to list 3. Okay, the first one that comes to my mind is 3 times 4. All right, 3 times 4, I could make a rectangle that has a base or height of 3, and the other side would be 4. So let's go ahead and do that. I'm going to use a little straight edge here. I think I have one of my, actually, I have a post-it note. I'm going to use a post-it note instead of a ruler. Post-it notes are also good to have on hand. Okay, so I'm going to start over here, and I'm going to make a 3 by 4. I'm going to go my height of 3, 1, 2, 3, and my base of 4. 1, 2, 3, 4. Now remember, I'm making a quadrilateral, not a rectangle or triangle, so I'm going to connect these all the way around. See that? Okay, there's one. That's a nice one, right? So I've got my 1, 2, 3, 1, 2, 3, and I've got my base 1, 2, 3, 4. Notice this one overlaps. Okay, now what's another way we can make 12? 2 groups of 6 or 6 groups of 2. We could do it either way, right? We could do 6 groups of 2 or 2 groups of 6. It really doesn't matter. Same with this. I can rotate this and stand it up and make the base 3 and the height 4. Like, I can even do that real quick. So I've got 1, 2, I'm just going to do this 1, 2, 3, 4, and then across 3, 1, 2, 3. See? There's another one. It's the exact same. Remember that commutative property? We can rotate. All right, so it's the same shape, just rotate it. 3 and 4. I can do the exact same thing with 2 by 6, but I'm just going to draw a 2 by 6. I'm going to say my height is 6. So I'm going to go 1, 2, 3, 4, 5, 6. Use my straight edge here. And draw my straight line. Okay, and then I'm going to go across 2 at the bottom. See that? And again, that corner overlaps. The corner, that's where the right angle is. See the right angle? That's where they overlap. Same with this. Okay, then I just have to connect it. Again, I can rotate it, and I could make my base 6 and my height 2. So I could go across the bottom and do that same thing, but I'm not. So another way we could do this, if we wanted to make something completely different, is 1 times 12. This would be the other way to make an area of 12. 1 times 12, that would be something tall, very narrow, or across the bottom. I'm going to do, let's see how many boxes I have across the bottom. Do I have enough to make 12? I'm going to start at the corner. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Cutting it pretty close there. What about up and down? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I don't have enough to make it a tall, 12 tall. It's going to have to be 12 as the base. So I'm going to go across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Just enough room here. And my height is just 1 unit. So it's literally just 1 bar all the way across. The base is 12 and the height is 1. 1 times 12. So all of these have an area of 12 square units. Okay, so all I had to do is think about the facts, the multiplication facts, the factors that would make 12. Good job, everybody. All right, I'm not going to do question number 3, so I'm going to skip this one. But I'm going to look at question number 4. Question number 4 says the area of the shape is 24 square units. Which of these statements is true about the area? And then it says select all that apply. That kind of lets me know there's more than one correct answer. All right, I'm going to zoom in on this one a little. So the first one says the area can be found by counting the number of squares that touch the edge of the shape. That touch the edge of the shape. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So if I count just the edge of the shape, I'm missing a whole bunch in the middle. So I don't think this one is true. I'm just going to put a question because I'm like, I don't think that one's true. Okay, this one says it takes 24 grid squares to cover the shape without gaps or overlaps. Well, if it's telling me that there are 24 square units and it says that there are 24 grid squares, I can assume that that is true. Now let's just test it and see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So yeah, that one works. Okay, let's keep going. The area can be found by multiplying the sides lengths that are 6 units and 4 units. Okay, well, if I multiply 6 by 4, notice I don't have that right angle, right? Because 4 is at the top and 6 is at the bottom, and I'm looking for, if I go back, I'm looking for that L, the right angle. And I can't make a right angle with 4 and 6, okay? So I don't think that one's quite right. All right, let's check D. The area can be found by counting the grid squares inside the shape. Well, that's what we just did. These B and D are very much the same. I just counted all of the little squares inside the shape, and that would work. Okay, now let's take a look at the last one. The area can be found by multiplying 3 times 4, or 4 times 3, and 6 times 2. All right, let's take a look at that. I'm going to pull out some crayons here. I love crayons. And I'm going to see where 3 and 4 are. I'm going to rotate my paper, and I can see my base is 3. See, the base is 3, and the height is 4. See that? And there's that overlap. Remember, we're looking for that overlap. That's the right angle. Now watch, I'm going to fill this in with my marker, and I can see that I have this nice rectangle, 3 times 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I didn't have to count all the boxes because I know that 3 times 4 is 12. We've got that nice right angle here, okay? And then, if I use a different color, let's use blue, and I do 6 times 2. Now this one's perfect. I don't need to rotate this paper around for that one because I can see the base is 6 and the height is 2. I had to turn the paper a little to see it here. The base is 3, the height is 4. But let's see. Here's my 1, 2, 3, 4, 5, 6, and my height of 2. 2 times 6 is 12. And guess what? 12 plus 12 is 24. So yeah, that would work. 12 plus 12, 4 times 3 is 12, and 6 times 2 is 12. And together, that makes 24. 24 square units. Okay, so I can see that E will also work. Well, we didn't like A and C, so B, D, and E were the correct answers. Those were the ones that were true. All right, this one is fun. Here are 2 copies of the same figure to show 2 different ways for finding the area of a shaded region. All angles are right angles, so they're telling us that everything in this shape is a right angle. And we're going to find the area 2 different ways. All right, these are super fun. All right, so sometimes it takes a little bit of visualization. You have to kind of imagine what the shapes look like. And I am going to show you 2 drastically different ways that I would approach this problem. The first thing I would do is I would make smaller sections of the shape. So one thing I would do is I would partition it right here. I imagine this like a house, and I just want to know the bedrooms, like what size are the rooms, right? And notice the 10 here is at the bottom, but I cut that off, so I can't use that 10 because the 10 is measuring this complete distance. So I'm just going to kind of cover that up. And I can see I have a 3 and a 5. See the right angle? Now the 5's at the top, but guess what? That's the same as the base at the bottom. I can just rotate that around. So I have 1. I'm going to do some color coding here. We're going to do this one blue, even though the whole shape is blue. Okay, so we've got 3 by 5. There's that right angle. See that? So I know that 3 times 5 is 15. Okay? Now, I've got this bigger area that I have to figure out, so I'm going to take and I'm going to make this small little section. I'm going to imagine like this is like a bathroom in my little make-believe house. It's small here. I'm just going to partition that off, and I can see I have a 1 and a 2. Okay? So I know 1 times 2 is 3. 1 times 2, I'm sorry, 1 times 2 is 2. Okay, so this would be an area of 2. Now I'm kind of running into some problems here because what I've done is I've kind of created this space that I have no idea. I have no idea what this is. Is it 2? Is it 6? Is it 3? I don't quite know. So this is where this one gets tricky because inside the shape, I'm going to use a yellow. Okay, inside this shape, we have a height that is 3 and a height that is 2. Do you see that? So together, inside this little shape here, which we think is a square, but we're not sure yet. We're going to wait and see. I have a height of 3 and I have a height of 2, which means that this is a height of 5. So the whole entire thing here is 5. Okay? Now I need to know what the base is. Now look at the bottom. Remember, the whole base is 10. The whole base is 10. But we divided it right here, and we can see when we divided it, this is 5, this is 5, that means this is 5. So we essentially cut it in half. We didn't realize that we cut it in half, but we did. So that means this is 5. And 5 times 5 is 25. So this would be an area of 25. So I've got 3 separate boxes. I've got a 15, which is going to be my 3 times 5. I've got my big box here, which is 5 times 5, which is 25. And then my tiny little box, 1 times 2, which is 2. Together, I'm going to add them all up. 25 plus 15, 25. 5 plus 5 is 10, plus another 10, so that would be 40 plus 2. 42 square units. Okay, now we're going to do something slightly different for the other shape. Now what I'm going to do is I'm going to use my ruler just as a straight edge, and I'm going to fill in the shape. I'm going to fill it in and make it one big giant rectangle. Okay, see that? Now I have this giant rectangle, and I have a clear base and height. I've got the base, which is 10, and the height, which is 6. So I can say 10 times 6, which is 60. However, the whole thing is not 60 square units because this is missing. This is what we need to take out of the shape. So if I look inside that shape, and I'm going to use, let's use a pink. I look inside the shape, I can see this small little section here, which is a 3 by 1. See that? 3 by 1. So this little area is 3. 3 times 1. Okay? And then I've got this section, which is 5 by 2, but not really. It's a 5 by 2, but we need to add 1 more for that height. Let me show you. This is 2, and this is 1. So together, that makes a height of 3. Okay? So my height is 3, my base is 5, and 3 times 5 is 15. So this is 15, and this is 3. So I know my answer is 60 for the whole space, 60 square units, but I've got to take away the 15 and 3. Now, if subtracting is a little harder for you, that is totally okay. Let's find the calculator. It is okay to take a look at the calculator here. And we've got 60 minus 15 minus 3. Same answer as the other problem. 42 square units. Okay? All right, so that is it for these questions. I just wanted to take a look at the first chapter, and we did questions 1 and 2 of the practice problems. We skipped 3, 4, and 5, and then we're going to skip 6. In the next video, we'll take a look at chapter 2.